All right, hello everyone. My name is Ben Lisbakken, and I'm an engineer at Google. And it looks like you guys have all made it to my session on fun hacks in cool JavaScript. So what I'm going to do is I'm going to talk about my process in creating the Google AJAX API playground. What I really wanted to do is just talk about some of the techniques that I used to create it and some of the things that I learned along the way that I thought were, really important things that I learned that I'd like to share. So let's jump right into the outline. First, I'll show you guys what the AJAX API playground is, since I'm sure all of you don't know exactly what it is. Then I'll go into some JavaScript. So I'll show some intermediate and advanced techniques that you can use in JavaScript. After that, I'll talk about some of the cool hacks that I did in the playground, some stuff that I really had a lot of fun doing. Then I'll go into XSRF, which is a security vulnerability. Excuse me. And after that, I'll talk about front-end web performance. So let's take a look at the AJAX API playground. What is it? It's an interactive JavaScript code editor that allows you to edit code and then run it on the exact same page. Its primary use right now is for showing Google AJAX API examples. However, it's an open source framework that I created, so you can really use it for any JavaScript code that you want to show. You can also edit HTML and CSS in addition to JavaScript. That's a recent feature that I added. And why did I make it? I made it because when I'm learning APIs, it's really difficult to go through the documentation and figure out exactly what's going on. It's also really hard to find what you can do with an API just by looking at the documentation. So samples are really king for me. I believe that if you look through 10 samples, then you'll have a better idea of what you want to do. And in addition, by looking through the actual code, you'll have a better idea of how to accomplish it. So let's go ahead and take a look at the playground. That is huge. Let's see. Can you guys see that pretty well? In the back? Can you guys see the code? Anyone back there? Looks good? Okay, so here's the playground. On the left-hand side is the pick div, and this allows you to select from various JavaScript APIs that Google offers and see some samples on them. So right here, I'm going to list some blogs. You'll see the codes over here on the right-hand side. It's a little bit squished because it wasn't meant for a projector, but down here is the output div, and it shows the output of the sample. Let's take a look at another sample, a calendar sample. So this is just a simple sample for showing the events from a calendar, and in this case, we're looking at the Google Developer Calendar. So you can see that one of the events is this conference. Let's go back up to a translate example. Up here, you'll see it's just really simple. Take some text, it's in Spanish, and it turns it to English. So let's look at the code. You'll see here, we've got the original text, the Spanish, and then down here is this block of code for translating it. So what if I wanted to edit this example? I could go ahead and throw an alert in here. I'm just going to alert the number 1. Then come down and click Run. And there you see it prints out 1, just like I wanted it to. So the reason why I created the playground like this is because when you're looking through sample code, it's really hard to go from seeing the sample code to getting to the point where you're actually going to be editing it and doing what you want to do with it. So the way this format works, it makes it a lot easier than seeing a sample, copying the code to a new document, putting it on your server, and then actually being able to play around with editing it. Instead, with the playground, you just jump right in, see a sample that you like, maybe you want to tweak it, see if it can possibly do what you're trying to do, and then run with that. So what happens if you want to debug? Well, I added some features in there for debugging. So right here, I just added a breakpoint on line 11. I'm going to go ahead and click Debug Code. And it's now going to pause it on line 11. And this right here is my continue button. I can continue through executing the code. Or if I want, I can open up Firebug Lite in the bottom. And I can actually log one of my variables. So I think up here, if you look, I have a variable in this function called content. So come back down here and see what content is equal to. And sure enough, we get a div. If you go look at the top, content is equal to a div that we've grabbed. So that's how you debug. Oh, well, let me show you really quick. Finishing through the breakpoint, it sure enough goes through, calls the alert, and then it will finish the translation. So that's how you edit code and debug it. What if you edit some code substantially and you want to hold on to it for later? There's a save feature. So you can go through and you can my IO sample. Big caps because it's a cool sample. Not really. And so now you have a new div when you go into the playground called saved code. And it's now got my sample that I've just saved. You can also go and share code with friends. So if you want to break out of the box of the playground and actually show someone else what you've done, you can click export. We'll now export the code to a standalone URL. So you can use this sticky URL to show to your friends, and it'll exist forever. And go in and see, and this is all of the sample code for that exact sample that I was just taking a look at. So there's about 188 samples in the AJAX API playground. So I really suggest going through and taking a look at them. I mean, a lot of people are interested in maps. So there's just a ton of different maps, samples for everything you'd want to do. Search as well. Putting search in your site's really easy, and there's samples for absolutely every different API call that we have. So if you're interested in JavaScript APIs from Google, definitely take a look at the playground. So let's go ahead and get into some meatier code. I want to talk about JavaScript. And the reason why is because lots of web apps almost all web apps use JavaScript. And JavaScript's really easy to use, and it's really easy to cut and paste. However, generally, people don't know JavaScript really well. So I wanted to take some time to talk about the coolness of JavaScript, some of the intermediate and advanced stuff that you can do in JavaScript. And I've always wanted to go to a session when I was learning JavaScript that would talk about some of these cool functions, some of the cool things that you can do. So a quick warning, if any of you are experts in JavaScript out there, you'll probably be bored for the next 15 minutes because I'm going to go through some intermediate JavaScript stuff. If you're a beginner, then you might get a little bit lost, especially if I'm talking too fast. I'm going to go through a couple really important concepts to learn in JavaScript, and generally you can't learn them in 15 minutes. So feel free to ask questions as I go through them, but also you can follow along with me on your computers, and you can check out the URL after to look at this stuff, and I highly suggest looking up additional information. Also, the code that I'm showing for you, I just wrote it up really quickly for this presentation, so it's not battle tested. It's not meant to be copy and pasted. It's just for education. So let's jump right in. I decided to add JavaScript samples for my presentation into the actual playground. Go ahead and delete that. And here they are. So let's start out in JavaScript with defining objects and creating prototypes. The first step is creating an object literal. So what's an object literal? It's just a format for defining objects in JavaScript, and it's a comma-separated list of properties and methods for an object, and it's a dynamic way to create an object, and it's used for creating a singleton, so just one instance of this object that you're going to use over and over again. So take a look down here. I'm creating a variable a, and I'm setting it equal to these brackets here. That means that I'm setting it equal to an object. And here you'll see the contents of this object. I basically have key value pairs, and the key value pairs are the property 1 is equal to the number 1. Then I have ARR, which is equal to an array. Then I have do this, which is equal to a function, and 2, which is, again, equal to an integer. So right off the bat, you can see that JavaScript's a really dynamic language. I've made an object that has very different properties in it. So if you take a look down here in the output, I'm just going to show how you use it. So a.doThis is, we're calling that function, and it is outputting 20, as you would see up here. And same with the array. We're going to a.rr, and indices 0 is, in fact, equal to 1, which you'll see up here. On to adding properties to an object. So it's easy to dynamically add properties to an object, because objects kind of just behave like hash tables, key value pairs. And I'm going to show you how to do that right here. I'm going to create a variable a, and it's equal to a blank object, an object with nothing in it. Down here, I'm going to give two properties, property 1 and property 2, and they're both going to be equal to integers. Now you'll notice that the syntax is a little different for both of these. One of these is a.property1, and the other one is using a as if it were an array. This is effectively going to assign the properties to a the exact same way. So another example of how JavaScript's kind of dynamic. There's a lot of different ways to do things in JavaScript, so it gives you a lot of flexibility. And then down here, I'm going to show how to dynamically add a new function to UA. So I'm going to create function 3 and set it equal to a function, which is just going to take property 1 and property 2 and add them together and return the output. Notice that I'm using the this keyword. In JavaScript, this just refers to the object that we're in. So right now we're in A, so we're referring to A property 1 and A property 2. So now let's go on to inheritance. In JavaScript, to do inheritance, you use prototypes. And so what you use prototypes for is to add properties or methods to all instances of an object. So I'm going to create a dog down here, and this is the constructor function for a dog, and when you create a dog, you're going to pass in a bark noise. In the constructor, I'm going to set this instances of the bark noise to be equal to whatever's passed in. So when you pass in the bark noise, that instance of a dog is now going to always have a bark noise. Down here, I'm going to use the prototype keyword. And the prototype keyword is the magic that makes inheritance possible. So I'm saying each dog is going to have a bark function. And I'm doing this just by saying dog.prototype.bark is equal to a function. So whenever I create a new one, they'll always have a bark function. Same with the numLegs property. I'm making it so dog.prototype is saying that each dog is going to have the numLegs property. Down here is how I actually create the dogs. I say new dog, and I'm going to have a tiny dog that yaps, and I'm going to have a big dog, which has a very deep, burly wolf. And after that, I'll assign some properties to these instances. I'll give them each a size. Just say it's tiny dog's tiny and the big dog's big. And this is just showing, on the last example, how you add properties to an object. Nothing too crazy on the output. I'm just showing that this did in fact work. The tiny dog is tiny, it has 4 legs. The big dog is big, and it has 4 legs. And here are their bark noises. Yap, yap, and woof. So you can override prototypes too. So if an object already has a prototype defined for it, then you can override it. You can rewrite it to do what you want. You can also create new prototypes for that. So you can do this on native JavaScript types as well. So you could do this for strings or integers or functions. You could actually override JavaScript's native behavior. Now, this is very dangerous to do that, to override a native JavaScript type, and so I'm saying this is a bad example. Please don't copy this one, because you could really screw things up for other people. And the reason why is because if you edit a native JavaScript type and you include jQuery, jQuery is going to be trying to use a string function just like it would expect it to work. But if you're changing the native JavaScript type, then when you include jQuery, it's going to fail. But why am I showing you this? The reason why I'm showing you this is because in some cases, you will want to override prototypes that exist. So for instance, if I was including jQuery on my site and I didn't like the way that they did one of their functions, or if I wanted to have each jQuery object have a new property or a new method across every single one, then I'd want to use this stuff right here. So here is a simple example where I'm changing the concatenation function for strings. Normally it just takes one string and concatenates it with another, but in this example I'm actually going to take one string, put a delimiter, and then add on the other string. So nothing crazy. The syntax for this is just like you'd expect. Just in the last example, you just define the prototype, but since the concat already exists, we're overriding it. Then down here, I'm going to add a new function onto strings. I'm going to make it so that you can call a string .reverse. So you can reverse a string in place. And all that's going to do is print it backwards. Down here in the output, you can see how it would work. If A was equal to ABC and B was equal to DEF, if we called concat like that, then of course we get that output. And A.reverse will reverse the string A. Conditional assignment. This is a very simple example to show. The reason why I wanted to show it is because for those of you that don't know it, you'll see this a lot, and I think it's elegant. I really like it. All you're doing here is conditionally setting B. We're saying that if A is equal to 1, then set B to 2. Otherwise, set it to 1. So now on to JSON-P. JSON-P is a little bit of a hard concept to explain. Basically, it's a technique for avoiding the browser's cross-domain restriction. So if you guys aren't familiar with that, that just means that if you're on domain 1 and you try and do an AJAX request to domain 2, because of the browser security model, you're not allowed to do that. But with JSON-P, you can actually get around that. And so what's JSON-P used for? Well, Google uses it a lot in our APIs. We provide APIs that allow you to request data from us in JavaScript and do it cross-domain. So the basics of it is that on the client side, you create a new scripts tag. You give that script tag a source, you give it a type, and then you add it to your page. So what's going to happen is whatever is, as you guys know, with a script tag, whatever is returned by the source that you're grabbing is then going to be evaluated by the JavaScript engine and run. Well, in JSON-P, the service is going to return the data that you requested in a format that will be executed by JavaScript. So right here, here's the source that I am setting the scripts to be equal to. And it's really hard to read, but you might notice that it's an object literal. I showed that. That was the first sample that I showed. So it's basically a string of data written as a JavaScript object. So if we look in here, what is this service that I'm doing? It's a web search, a Google web search, and I'm searching for dog. I don't know if you guys can see that. So in these results, it will return me the top queries for dog. The other thing to note is that all of this JSON is wrapped in a function call. So what's going to happen is when my page evaluates this response, it's immediately going to execute this function and pass in this object literal, and it's going to be evaluated. So I was calling my func. As soon as this script is added to the page, it's going to call my func, it's going to come in here, and it's going to log the response. So let's take a look at that response. Go into Firebug, check my log, and sure enough, this is the response. And it's got a nice, pretty format for us. Go through, and here are my 4 results. I have Wikipedia and dog.com. All right, on to anonymous functions. So an anonymous function is just a function that's dynamically declared that doesn't have a name. So right here is our anonymous function. All we're doing is setting the onload event to be equal to this anonymous function. Nothing too interesting there. But this is why we would want to use anonymous functions. And the reason why is because of the fact that JavaScript uses functional scope. What that means is that context, scope in JavaScript is defined by a function. So if you define a variable in an if statement or a for loop, it doesn't matter. All that matters is what function it's in. So if you have a function, you have stuff defined in it, it won't be visible outside of that function. So that's the functional scope for JavaScript. And the reason why this is useful to know is because a lot of times in JavaScript, well, in web pages in general, you always want to be including other people's scripts. Well, the problem with that is that all the names will collide. If you guys use the same names, then you're going to start having errors because you guys will override each other's data. So knowing that JavaScript operates like that, where if you have a function, anything defined in it won't be visible outside of it, you can actually hide all of your code. You can hide it so that your names aren't affecting the global scope. And in JavaScript, in the DOM, the global scope is the window object, just a little tidbit. So down here, I am going to use this to my advantage by creating an anonymous function, which spans down to here. I'm going to wrap it in parentheses so that returns the function. And then right here is the really important part, where I'm going to automatically call that function. When that function gets called, it's going to define everything inside this function. And everything inside of this function is now going to be invisible outside. So what I've done is I've created a function that has no name. I've written all of my code, let's say my 2,000-line project, I've written all my lines within this anonymous function. And now when someone includes this on their page, it won't pollute any of the global namespace. There won't be a named function there, any of my variables inside of the function, none of them will exist in the global scope. So we'll have no namespace collisions. Excuse me. But what if I wanted to export something from the inner function to the outside? Here's how you do it. As I said, the window object is the global namespace. So what I would do is I'd attach a new variable to the window object, the global namespace, and I'd set it equal to a property or a method that I wanted to export. So in this case, I'm exporting visible outside function to the global namespace. And down here, I just did a simple test to see what is the value of these two functions inside of the anonymous function, and what is their value outside. And you can see that from the inside, we can see both of them. They are both of type function. But from the outside of the anonymous function, you can't see the invisible one because we never exported it. However, you can see the visible one. So for third-party libraries, they all are using anonymous functions to hide all of their local variables. And it's a good practice to do it with your own code because you never know when someone's going to reuse your code. All right, on to a really fun topic, closure. So closure is a source of a lot of power in JavaScript. And all it is it's when a function is defined within another function, and that inner function has access to the outer function's context and scope, even after that outer function's already closed. So right here, in fact, in some of my examples you've already seen, the last example had a closure in it. I had an anonymous function with code defined in it with other functions, and that was already an example of closure. But right here, it's just a very simple, obvious one. I have an inner function, and I have an outer function. And in the inner function, I'm accessing these two variables, and these two variables exist in the outer function. So that's all a closure is. Here's how you'd use a closure. One common way is with setting events. Basically, when an event handler is triggered, if you're trying to print out a value, then whatever you're trying to print out is going to be the value at trigger time. But what if you wanted to hard code a value into that event so that when the event triggered, it printed out whatever you wanted when you would set the handler? Well, you'd use closure for this because you can access the outer functions variable even after the outer function is closed. You'll understand more in just a sec. So this is the bad way. I'm going to create 5 buttons. I'm going to create 5 buttons the wrong way, then I'm going to create them the good way with closure. So the bad way, here is setting an on-click handler. The bad way, I'm just making it equal to a function that alerts a variable. And the problem with this is that I is going to be, when I click this button, I is going to be equal to whatever I is at the time that this is clicked. So in this case, the for loop's going to go through, it's going to iterate to 5, and then when you click the button, I will be equal to 5, and that'll happen for every single one of the buttons. But what I want the behavior to be is each button that gets clicked will output what number button it is. So, 0, 1, 2, 3, 4. So for that, I would use closure. If you take a look down here, this is my good setters. Button.onClick is equal to a function that I'm executing. So I'm executing a function, which is then going to return a function. Up here is the function that I'm executing. I'm passing in I. So let's say let's go through the first iteration. In the first iteration, we're going to call button click. It's going to pass in 0. Button number is going to be equal to 0. Within this context, we're going to have access to that variable. And then we're going to return a function. This inner function, because it's a closure, has access to the outer function's variables, aka button number. So when you click this button that uses closure, it's going to alert whatever value is snapshotted inside of it because of closure. So it's a tough concept to understand. It definitely took me a little while to pick up on it. So hopefully I explained it decently. At least you guys are aware of more things that exist in JavaScript, more fun, cool tricks that are very heavily used. So I hope that you guys will go explore more information on those. Let's get into some of the fun things that I did in the playground to make it possible. So there were 3 things that I wanted to cover. One is executing arbitrary code safely. The next is adding the Debug Bar and Firebug Lite into the output. And the last one is adding breakpoints. So executing arbitrary code. I don't know if you guys are familiar with eval, but eval lets you take a string, so just a normal string, and then JavaScript will evaluate that string as JavaScript. So if you passed in a string variable 1 is equal to 1, and you pass it into eval, then you now have this new variable in your code. Well, as you guys saw, I allow you developers to edit code in the playground. And so that means that I have to let you guys be running your own JavaScript, whatever you guys want to be running. And it's bad to use eval because it's going to be happening on my domain. So you developers will be writing code, JavaScript, that gets run on the google.com domain. This is really bad because you guys could write code that would steal cookies, steal authenticated sessions, and for obvious reasons, that's really bad. So I had to come up with a solution that would sandbox the code that you guys are writing so that you couldn't do evil hacks. So the solution is an iframe, and it's creating an iframe on another domain that doesn't have access to any of these cookies or any private secure resources. So when the user writes code on the playground and then clicks run, the playground takes that giant chunk of code that they have, it sends it to another server. That server then stores it in the database, and then it returns a unique URL to that code that's over here. The playground takes that URL, and it creates an iframe to that code. So then the playground's got this iframe with the code running in it, and it's a beautiful little sandbox because iframes can't talk to parent frames if they're in different domains. So it completely cuts off any vector of attack in stealing cookies or any evil JavaScript stuff bad developers might try and do. So let's talk about adding the debug bar and Firebug light into the output. This was an interesting problem because I wanted to add my code and my interface into code that you guys are writing. So I don't know what you guys are writing, but I don't want to conflict with it. So what I did was use some of the tricks that I was showing back when I was explaining the JavaScript stuff. I used an anonymous function to hide all of my code. You can see here I have a variable anani that I'm setting equal to this anonymous function with all of my code that's going to insert the debug bar and insert Firebug light. And so what that'll do is when the code gets sent over to the iframe, it will make it so that my code won't be in the namespace. So if you guys are writing a bunch of global variables, I won't conflict with you. Now there's some interesting things down here on the last line. What I'm doing is I'm taking this anonymous function, which is actually defined in my playground JavaScript, and I'm using a fun little method called toString. Now you can imagine that you would be able to call toString on an integer and turn it into a string, but not too many people know that you can take a function and call toString on it. The reason why this is nice is because it's very convenient. Since I'm taking code and I have to turn it into a string so that I can send it over the wire to the other server, I really don't want to write my code in a string. Like I don't want to put parentheses, or quotes around all these lines and have to write new lines in there because it's very ugly code. So I did this. I created an anonymous function. I turned it into a string. I wrapped it in parentheses and added the auto-execute parentheses so that once it ends up on the other server, it'll be a string, and it'll be an anonymous function that auto-executes itself. So on to the real fun, adding breakpoints. You can add breakpoints in JavaScript via an extension. So you guys are probably all familiar with Firebug, and Firebug has access to the JavaScript engine. So when they're creating breakpoints, they're actually stopping and starting the JavaScript engine again. So they have direct access. I didn't. All I have access to is JavaScript. So I wrote breakpoints for JavaScript in JavaScript. So it was a fun little problem. One of the interesting things about it was preserving execution context so that once I went into a breakpoint, after I continued out of it, it would still contain the correct context. That way, any variables that were being used would still have access to the local variables that they should. Another fun problem was making sure that Firebug still had access to print out the local variables while in a breakpoint. So here's the before and after code. The before code is the code that you, a developer on the playground, might have written. And the after code is what I've done. I've parsed your code and added in some stuff to make it possible for a breakpoint to occur. So on line 9 is where we've inserted the breakpoint. If you come down here and look, right after where you inserted the breakpoint, I start inserting my own code. I call this function setContinue, and what that's going to do is it's going to set a global variable for me saying that, yes, we are, in fact, in a breakpoint right now. Then I've got this big function here, and you'll notice that this is a closure. I've got this big function here, and it's going to contain my logic that allows me to loop back over myself until the user has clicked continue. So I've got this if statement, if window.do continues. So if the user hasn't clicked continue, then call set timeout and recall myself the closure function breakpoint at line 9. Otherwise, if the user has clicked continue, go ahead and execute the rest of the code that was supposed to be executed. So that's lines 10 and 11 up here. So this is interesting. I just wanted to point out that variable A equals text and alert A, those are now possible because it's a closure, and so those still have access to this variable up here. Now on to the Firebug problem. Why was I still able to print out local variables with Firebug? Well, the problem is that when you're in this set timeout loop where it's looping every 100 milliseconds over my breakpoint function, Firebug's over here. When you try and log with Firebug, Firebug's not in the same context. It's in a completely different context, so it can't see these local variables. And if some of you are familiar with the apply or call functions, there's no way to work those in to force them to be the correct function context. So I had to get a little bit more creative than that. I basically made this big hack where I went into Firebug's code, their JavaScript code, and I edited it so that if Firebug is trying to log something and it sees that you're in a breakpoint, then it's going to add whatever you're trying to log into a global queue. In my breakpoint, you see this if statement right here. It's going to check that global queue, and if there's stuff in the global queue, then it's going to log it. The reason why this works is because when you log it in here, it has the correct context. So it was my little ninja way of sneaking Firebug into the correct context. All right, so enough about JavaScript context and all that stuff. Let's get into security. So XSRF is a common security hole, and it's a very serious one too. I definitely didn't know about it when I was creating the playground, but after doing a security review, I certainly found out about it. What it is it's when evil.com tries to run an action that requires authentication on good.com. So without XSRF protection, the user, if the user is still logged into good.com, that action will be run. And the reason why is because when the browser navigates to a URL, it automatically is going to send all of its cookies in the HTTP headers to the server. That means if you're still logged into a site and you go to that URL, it's automatically going to send your login cookies to that site. So if evil.com's linking you there and it's posting some form to that site and you're still logged in, sure enough, your cookies are going to get sent and that site's going to allow you to run that action. So an example in the playground would be the save action. If evil.com were to link to save code in the playground and you, the user, were still logged in and clicked this link, it would allow evil.com to save code into the playground for you. So why is this bad? It's bad for obvious reasons. It allows evil.com to access and modify private data on authenticated sites. So one way to fix this is to only let known domains access and modify sensitive data. The way that you do this is by creating a unique token that the server and client are going to share, and that's how the server is going to validate that we're coming from the correct origin. Let's take a look at this diagram I created. In the playground, when a user clicks login, it's going to send the login request to the server. The server is then going to create a unique token. This unique token's then sent back to the client. The client immediately stores it in cookies, and whenever they try and perform an authenticated action again, they're going to grab those cookies, they're going to take that unique token, and they're going to put it in a post form to be sent off. The reason why this is important, the whole cookies part, grabbing it and putting it in a post form, is because in JavaScript, you can only grab cookies for the domain that you're on. So if I'm on code.google.com, I'm the only person that can run JavaScript to access those cookies. Evil.com can't access those cookies. So if I require on the server that you send in the post form a unique token, Evil.com can't do that token because they can't grab those cookies from code.google.com. Yes, the cookies will be sent in the HTTP headers, but we're specifically looking in the CGI args to make sure that this unique token is being sent. So in that manner, you can verify that on the server that the request is coming from the origin that you want. So for authenticated actions, we only want to let it come from domains that we're aware of. All right, on to front-end web performance. So performance is really important, and Google's done a lot of studies that show that when you increase the performance of your site, you receive more traffic. And I got some of these numbers from Steve Souders down here. I don't know if you guys were able to attend his session. I think it was yesterday. That's very good, but thanks for the numbers, Steve. So if you increase your site by 500 milliseconds, well, at Google, we did a test where if we increased the load time of Google by 500 milliseconds, then it would decrease the traffic by 20%. So that's definitely significant. And right now, back-end servers are really fast. So the amount of time that it takes for you to request an HTML page from a server and actually get it back, I mean, it's really fast. You can optimize it, but you're only going to be optimizing milliseconds. If you really want to optimize the user experience and make it so that a person's seeing a web page as fast as they can, then you want to focus on the front end. So I should also mention that all the stuff I've learned from Steve, so you guys should definitely go check out his blog because he's got a lot of really good resources. So optimizing the playground was a really fun thing for me because I got a lot of gain out of it with fairly little work. It only took me maybe a day or two to do a bunch of these things, and I went from a 400K app down to a 90K app, and the page now loads with a primed cache in just under 2 seconds. So there are several things that I did. These are just the really simple, easy ways that you can increase performance, and that's gzipping responses, minifying JavaScript using correct script tag placement, optimal cache headers, and minimizing images. So I'm going to go through these, explain a little bit about them, and show some demos. Gzipping is the biggest space saver. Everyone should definitely be doing gzip because you can get a 70% space savings, and it usually is only 1 or 2 lines of config on your server. Gzipping, everyone knows about zipping a file. Gzipping is just the same. You compress it on the server when someone requests a resource, and then on the client, they're going to get this zipped response. They're going to unzip it and then evaluate it. One interesting thing to note is that I was using App Engine, so I didn't have to worry about this at all. App Engine has it on by default, but for things like Apache, it's really easy to Google how to do this. So let's take a look at the space savings I got. Going to go into Why Slow and take a look at the components. So here you can see a couple of the JavaScript files that I have, and I went from an original 55K file, and now it's about 18K, and then a 35K file down to a 10K file. So for adding, one line to your config, it's pretty much the easiest thing you can do to increase the performance of your website. Minifying JavaScript. What that is minifying JavaScript as well as CSS. What that is just taking out unnecessary characters. New lines, comments, tabs, spaces. There's a bunch of tools for doing it. There's also tools for doing JavaScript compiling, where you actually use like Rhino or something to evaluate the JavaScript and change some of the logic. But these are just minifiers. I use YUI compressor. It's good because I can use it in my open source project. It's stable, and it's fast and does a good job for me. Minifying JavaScript is bad for production, good for production, but bad for development, and the reason why is because it takes out all the unnecessary characters. So if you're developing, you want to be able to read and easily edit your code, and you also want to be able to find errors. So if you use minified JavaScript while you're developing and you have an error, then the error is pretty much always going to be on line 1. You can save 20 or 30% of the size, so I'm just going to show you guys really quick what it was like for me. I've got this script here. Just want to show you guys one line of it. This is the only important line. This is the line that does the magic. It compresses my interactive logic script. Let's go ahead and run that script. So here's my ugly minified JavaScript. So you can tell why you wouldn't want to develop with this, because it's very hard to read, but it's perfect for production because it's optimized. Down here are the sizes. So before I ran minify on it, it was about 40K. And then down here, after I minified it, it was 22K. So in this case, I got a 50% savings, but that's not the actual case, because after I gzip these two files, I only get about a 30% savings. Script tag placement. This definitely can make or break your web application. You have to be very wary of where you're putting the script tags on your page. If you put lots of script tags on your page, it's definitely going to slow it down. And if you put script tags in the head element, that's bad, because as the browser is going down and parsing things on the HTML page, it's going to get to these scripts, and it's going to start downloading and executing the scripts. But that's not important to the user. The user doesn't care. The user wants to see the layout of your page when they first go to it. They're not going to be able to use any function on your page in the first 100 milliseconds that it's loaded, so you don't need to have the function there for them. Instead, it's more important that a user sees everything immediately. And so by putting script tags in the head, you're basically slowing down the browser from rendering what it, the layout. So what you do want to do is put script tags at the bottom of the body. You want to dynamically append script tags as well. That's even better, but you can only do that if the scripts don't rely on each other. So I'm going to show some timelines. I like to use Safari's editor, network timeline. Let's open up all three of these. So I'm just printing out the code to the page so you guys can see it. So this is the bad way. This is how you don't want to do it. This is adding 5 JavaScripts in to the head element. It's bad because there's a lot of them. It's better to just have 1 JavaScript than it is to have 5. And it's bad because it's in the head element and it doesn't allow the rest of the page to render first. You'll see over here, by doing it this way, you've got this stair-step effect. So 1 JavaScript downloads and executes, then the next, then the next, then the next. So bad behavior. Better behavior would be to just have 1 single script and have it at the bottom of the body. So taking a look at this, gives you pretty much what you'd expect, just 1 JavaScript loading. It's definitely faster. And here is how you would dynamically append the scripts. Remember, you only do this if the scripts don't depend on each other. So up here I've got my nice little function, dynamically append script. I'm just going to create a new script element, assign it source, give it a type, and append it. Down here, I am going to take my 5 JavaScripts, and I'm going to load them. And you'll notice that the benefit of this is that when you dynamically append them, all of the JavaScript will download in parallel. So the browser can start downloading all 5 of these JavaScripts, and then it will execute them as soon as they download. So that would be bad if the JavaScript has to execute in a certain order, but otherwise it's certainly better than putting a bunch of script tags at the top of your page. Cache headers. So I'm sure you guys are familiar with setting cache headers. Basically, just what you want to do is set the expires header far in the future. What we do is we set our headers for about a year in advance, and we just use different names for our files. So we version our resources with an MD5 sum. So if JavaScript version 1.js, set it for a year in advance, and so that takes advantage of the cache. If we never change the version of our JavaScript for a full year, then everyone out there has got it cached for a year. Otherwise, if 15 days later we decide we need to release a new version, then we'll release JavaScript 2.js. And since it's a new name, it won't be associated with the cache of the other version. So we've got the best of both worlds. We can release new versions as fast as we want, but if we don't release a new version, then it's going to be cached for a long time. So if you want to see what other companies are doing with cache headers, you can use any of these tools below to inspect the requests that are happening in your browser, and you can actually inspect their cache headers. And setting cache headers is pretty easy. Again, you just do it on the server in the config. Oops, I didn't mean to escape out of there. Minimizing images. So images take up a lot of space, and there's two things that you can do to prevent this. Compressing images and using image spreading. Here are 3 images, and I'm going to show you how to compress them and then how to sprite them. So first, I want to use this cool tool that the Yahoo guys just bought. It's called Smush It. Go ahead and click that, and it's going to take all of the images on my page, and it's going to optimize them for the web. So they're still going to have, roughly the same quality. You won't be able to tell the difference in the quality with your eye, but it's going to make them a lot smaller. So this is kind of the same thing as if you go into Photoshop, and when you've got a picture, you click Export for web optimization. See here I saved 12K, which is actually a significant amount. Let's say that the playground is 10K right now, so that would be saving 10% on the website. So when you have a lot of images and you optimize them, you can actually save a decent amount of bandwidth. Spriting images. So spriting images is when you take multiple images and turn them into one image, and then the way that you address each different image is with CSS rules. So here are 3 images. Here is what those 3 images would look like as one image. You can tell that I'm just accessing sprite.png here. And the way that I created this is with this nice tool that I found online. It's called SpriteGen, and it's very simple to use. You just zip up all of your images. So I've got an archive of all my images. There's some options that you set, and then you click Create Sprite. And it's going to give me my image right here. I can download it. And I can also grab the CSS rules. So these are the rules for displaying each separate image. And so why would you want to use image spreading? The reason why is because if you've got 50 images on your page, then the browser is going to have to do 50 separate requests for those images. It's much better for the browser to just do one request for the image for all your stuff. And actually, if you look through a lot of different properties that Google owns, and I'm sure other major properties or other major companies like Yahoo, you'll be able to find their sprites very easily. Like there's giant sprites for YouTube, for instance, and you'll find like one image that has all the icons that you'll recognize that are used all across YouTube. Great, so I covered a couple different topics. Maybe I bored some of you with too much code or whatever, but if you guys have any questions, please feel free to come up to the mics, and thank you for coming.
That was a very interesting talk. I have a question though. Regarding your breakpoints, the place where you had written for the code for the breakpoints, and you said it's the user's code is actually running on a different domain.
Yeah.
In an iframe.
Yeah.
So if you could go to that slide, please. So how is the user's code kind of getting embedded in your else part when it's actually in an iframe?
Okay, so are you asking how did I get the code and put it in the else, or are you asking how does it get to the iframe?
Yeah, what I'm asking is, because this code, the var a equals text and alert, is actually a part of the iframe code. So how would it actually how would you execute it at that point after your breakpoint is done? Yeah,
so the answer is you can't. The way that it happens is that right here, when I'm typing code, when I type, alert, and I put a breakpoint in right here, as soon as I go to debug this code and click run, what's going to happen is in my playground code, I'm going to have this block of text. I'm going to parse this whole block of text, and I'm going to add in my breakpoint code. And then, after I parse in that code that I just showed you before, then I send it to the other server. And then it sends me back the unique URL, and then I create an iframe to it. So you can't do it on the fly.
Okay.
Because,
Okay.
Does that make sense?
Yeah, and I have another question for you. The place where you dynamically appended the scripts.
Yeah.
Is that going to be 5 separate requests, or is it going to be one single request?
It's going to be 5 separate.
Okay. Thanks.
Yep.
So on your add properties to an object slide.
On which slide?
Yeah. If you could just jump back to that slide. Oh, yeah, sorry.
This one right here?
No, actually the code, sorry, in the playground.
One of the JavaScript ones?
Yeah.
Object literals?
No, add properties to an object,
Oh.
the second one.
Yeah.
Right, the a.function 3 equals function, right?
Yeah.
This scope you state is the function, but what happens if the function's called within an on-click or something? Because at that point, the scope is the event, right?
It's the event handler. So, well, actually, no, it'll refer to the DOM element. So if you referred to this on an on-click, then you would get the element of whatever.
Right. So then, what do you do? What do you do in that case?
What do you mean? What do you do with it? Oh, what do you do in that case?
Yeah, because the properties.
Well,
property 1 and property 2 are not going to be accessible at that point in time. So how do you scope this function such that I can still call this as part of, in response to a click or some other function? I mean, I want to still be able to get to property 1 and property 2.
Okay. So someone said it down here. Was it you, Jeremy? Yeah, so that was one of the other examples that I showed that was enclosure for events. So because in this event, when I have an on-click handler, this is going to be referring to button. Right? And so, I don't want that. Instead, what I wanted this variable I to be passed in. And so what I had done is I'd use closure to basically snapshot I and get it in to this outer function so that the inner function could then call it. So the way that closure works is that an inner function can access the context of the outer function.
I know that part, but I'm just saying that I'm asking you, how would you rewrite that function so that you do still have the scope of A in the context of the fact that it's being called within an event?
What you can do is you can actually say var self is equal to this, and then I could pass self in, and then up here I'd have self, and then I could call self dot I forgot, property 1. Does that make sense?
Sure.
You could essentially grab the this keyword in whatever you are. So in the last sample, if let's see, where was it?
Yeah, essentially you're creating a closure where you're going to keep.
So in here, if I were to create var button is equal to document dot create element a new anchor, and say button dot on click is equal to a new function. If I wanted to pass in, if I wanted the inner function to be able to have access to this dot property 1, then what I would do is I would go like this.
To store a property, which is.
I would say self is equal to this. So now I've got access to it.
And then just do a
I'd call button click, and I'd pass in self. And up here I'd create my closure. Click. So I just did that on the fly. Let's see if it works. Oh wait, I didn't put the button anywhere. Let's see. What am I looking for? Why am I blanking right now on get?
You could just return a function which does the self dot.
Get
self
element
property 1, self property 2.
By tag name body dot append child button. Oh, thanks guys. This is not going to work because this is at the top of the document. Hold on a sec. Let me. The body won't be defined at that point. So let's go ahead and edit the HTML. Oh, okay. Looks like the JavaScript is in the body. Okay. Please work. The button has no inner HTML. Come on, guys. There we go. There's my button. There we go. That's property 1.
Awesome, you did, right?
So I could export this and go ahead and send it to you.
Thanks.
I was just going to ask, when you overrided the string to concat,
Yeah.
I was curious as whether that would override the plus operator between strings, and then also if it doesn't, can you
Override the plus operator?
The plus operator like in C++.
I don't think that's possible. Maybe someone else knows.
You cannot.
I don't think so.
No
Yeah.
overload.
Cannot. So by overriding concat, string plus string would still just concatenate it.
Because you can only do it with with types, so it's an operator.
Okay.
Yep.
Thanks.
Yeah.
Totally unrelated question.
Sure.
I'm having a problem trying to control the context of document.write. I've got an issue where I'm dropping something, and I wish I could move that. Let's say I have an add code, and it's when I get it back, it's using document.write. Have you had any or heard of any experiments where people were able to control that?
Generally, you shouldn't use document.write.
Yeah, I know, but it's a third party,
Oh, so you have to use document.write?
They're using document.write in their code, and we're just making reference to the script.
It sounds like I'd have to see the code, so maybe we can talk right after.
All right.
Would that be okay?
Hi. You had that trick of sending your code to a server, which then basically sends it back to you with a unique URL to stick it in the iframe. Yeah. What would happen if you pointed the iframe at like a data URL?
At what?
A data URL.
A data URL?
I think that's what it's called. It's like a URL where you can hard code some data in. Is that what it's called? Do people know what I'm talking about?
I mean, it's gonna try and render the iframe, and since it's gonna be data and not HTML, it's just gonna fail.
Okay.
I mean,
Maybe I'll have to try it. Thanks.
Can you actually change the prototype property for the function object itself? And have you done anything interesting and needed to do that ever?
I believe you can, but it's a bad idea because everyone uses functions. So.
Hi. Is it not possible to load JavaScript files dynamically as the document is being loaded? Remember how you added the 5 files at the end and they were running in parallel?
Yeah.
Well, why not call, as the document is loaded, have like points which execute dynamic loading. So you don't manually code it in, but the server executes JavaScript code. So it renders on the client side JavaScript code for dynamically loading different JavaScript files so that as the document loads on parallel, the JavaScript files will also load.
So actually, my example does actually do that, and let me show you why really quick. So what happens is my dynamically append, these happen in the head element. And so what I'm doing for each dynamic append is I'm appending it to the head. So the browser right now is parsing and executing all this code. Meanwhile, imagine right after the script tag, I'm now adding all these new script tags after it. So as soon as it's done with this block of code, it's going to start executing or downloading those scripts that I've told it to do. But because they're dynamically appended, it frees up the browser thread. So the browser thread sees it, and it goes, oh, here's the script tag that I need to do. It starts downloading it, but then it moves past and keeps going. So that's why in the timeline you saw that, this isn't Safari, but in the timeline, that's why you saw they all started at the same time. The reason why is because browser thread came down. Okay, I need to start downloading this. Okay, I'm done. I'll wait till it comes back and executes, or it comes, finishes downloading before I start executing it.
Yeah, I was thinking you're already doing it. I was thinking of more of the same lines, but where you just have a script tag without type, script, dynamic load, and script. Somewhere along the body, not at the beginning, but you essentially break the body into different portions.
Yeah.
And then you just load it at different parts of the body. That's
yeah.
all. But yeah, that's cool. Okay. Thanks.
Anything else?
Hi. Is it possible to extend a namespace like you created with the anonymous function across multiple JavaScript files?
Yes.
Yes? Would you just make a non-anonymous function?
You're just saying like use basically the same variables across functions, but each file is going to have its own anonymous function. Is that what you're saying?
Well, I saw that you used the global namespace to pass those variables, but I was wondering if you could keep it in the same namespace and not use the global namespace.
I think I know what you're talking about. Let me actually go to the code that I wrote for the playground and see, where is it, anonymous functions? I had a link in here for. So what I'm doing here is, right at the start of all of my code, I'm declaring an anonymous function. And then all through here, all this stuff is just local to this function. It's never going to touch the global namespace at all. Then at the very end, I go through and I create this variable, is, on the global namespace. And it's going to be equal to a new instance of all of my code. And so basically, I've created one pointer on the global object that is now going to have, this one variable is now going to have access to everything that I've created inside. So I've been, I've kept my code very green.
Yeah. Okay.
No, minimal pollution.
Nice. Okay.
Does that answer your question?
Yeah, it does. Yeah.
Okay. Great. So for those of you out there that are JavaScript experts, please, check out the project, fix my code for me, and create your own samples with the framework because it's pretty easy to do. Yeah.
So my question is, I've heard the argument against gzipping as well, and I'm just wondering, I like the idea. I've always liked the idea of minimizing my JavaScript files, but like for instance, like one of the reasons jQuery doesn't gzip their files anymore, they only minify them, is because they found that the potential overhead from gzipping them, from having to unzip them on the client side, tended to be less effective than just not zipping them at all. And I'm wondering when, I guess, as a developer, you should consider zipping your files as opposed to just minifying them and throwing them on the server.
I've never heard that argument, that the processing overhead takes more time. Because I'd imagine if someone has a really slow connection in a slow computer, let's say an 800 megahertz computer and a 56K modem, it's going to take a lot more time to download that extra 50K versus unzip it. Okay. But Steve Souders would definitely be the better person to ask because this is what he studies at Google every day.
Sure.
So
pay him a visit.
Yeah.
Okay. Thank you.
Uh-oh. I know this guy.
This is just an easy question. Do you have office hours today, Ben?
I do have office hours today.
When are they?
I think they're right after this session.
Do you want everyone here to come see you?
No. I'm just kidding, yeah. If you guys have any extra questions, please, it's just over on the other side. You'll see all the booths with windows on them, and that's where all the Googlers are hanging out to answer questions. So I'll be over there at the AJAX API booth. So please come see me. Thanks to it.